Biological brains excel at connecting ideas, but they struggle to hold on to specific data points with perfect reliability. For centuries, the primary solution was to offload that information into physical tools. During the Renaissance, scholars developed commonplace books to manage this. As seen in these detailed technical sketches and notes, they weren't just journaling, they were building a systematic, reusable intellectual resource outside of their own heads. In 1945, engineer Vannevar Bush proposed a theoretical leap called the MEMEX, moving past simple recording toward a model of associative linking. This machine was designed to store vast amounts of information on microfilm and retrieve it instantly. By creating associative trails between documents, the device was intended to augment human thinking rather than replace it. These historical systems were ingenious, but they functioned essentially as physical filing cabinets. Using them effectively required a massive, continuous manual effort from the scholar. Today, that manual effort has moved into the digital world through the second brain methodology. We use applications like Obsidian and Notion to capture and organize our digital lives. The primary goal of these systems is storage and retrieval. They are designed to provide a reliable answer when you ask, "What do I know?" However, the digital second brain soon hits a critical bottleneck. It is still entirely dependent on the user's energy. The software is a silent, static container until a person decides to interact with it. Because the system cannot perform the thinking itself, the user still bears the full cognitive load of searching for notes and synthesizing the data into something useful. A perfectly organized digital notebook provides little value if the owner is too overwhelmed by their daily workload to actually process the information stored inside it. While we were learning to manage our notes, an entirely separate technology emerged: generative AI and autonomous agents. Frameworks like OpenClaw give AI the ability to perceive digital environments and use tools. These agents are built for autonomy and execution, rather than simple storage. These agents address a different requirement than a personal knowledge base. While a second brain catalogs the past, an agent evaluates the present and asks, "What should I do?" These systems can plan multi-step actions and execute tasks across different applications without a human needing to prompt every single move. This gives the AI a high capacity for action, but it creates a new problem. The agents often lack the deep, personalized context found in the user's historical records. The convergence happens here. We are plugging the trusted memory of a second brain into the reasoning engine of an agentic framework. This fusion creates a personal cognitive operating system. The software functions as a dynamic actor that uses knowledge to drive decisions. Instead of a person manually searching through old folders, the system automatically retrieves relevant evidence and connects disparate ideas as they become necessary. The AI partner can now draft documents and coordinate specialized agents to perform research, all based on the owner's specific historical data. This partnership turns the second brain into an active participant that reasons collaboratively alongside the human user. Delegating execution to an autonomous AI system introduces a significant risk regarding trust. If an AI makes a decision on your behalf, you must be able to verify the exact data it used to reach that conclusion. Tracking authorization and version history is difficult when multiple AI agents are constantly interacting with a large living knowledge base. Without verifiable trust and context, an autonomous AI partner becomes a liability rather than a collaborator. To maintain trust, a governance foundation must sit beneath the agents and memory. This substrate, like Context Nest, ensures every piece of data is tracked and verified. It answers the critical question: which knowledge was authorized, current, and actually used when that specific action occurred? This governance provides version identity and point-in-time reconstruction. It makes the actions of both the human and the AI fully auditable. The evolution of these tools maps a path through memory, knowledge, and intelligence, arriving finally at governed cognition. Today's second brain movement is a foundational step toward a trusted ecosystem where humans and AI safely delegate thinking and execution to one another.